And she was there. So, welcome back, you guys. So, we're going to do a little discussion, and in this discussion, you do not need any paper or pencil. You're just going to listen and participate. So, students over here, if you guys want to come over here, you can sit in the desk. You can sit on the floor. Okay? You just leave your stuff there. Just leave your bags. You guys can sit on the floor. It's awesome. It's not going to see you. Hi, you guys. This is so cute. Hello. So today, like I told you, we are starting Unit G. And the purpose of this lesson is to introduce the key parts of a function graph, of a first derivative graph, and of a second derivative graph. So, one of my questions for you guys, how many of you are in physics or are going to take physics next year? Oh, a lot of you. Okay, so this will help you in your other classes as well because the first derivative graph is velocity and the second derivative graph is acceleration. So the stuff you're learning today will also help you in your physics class. So what I'd like to start off first is to see what you remember. What do you know about the function graph and the first derivative graph? What do you know? Logan?
The position, if it's above the x-axis on the first derivative graph, the slope is positive. If it's below, the slope is negative at that point on the function graph.
So positive slope and negative slope. Okay. Karen, what were you going to say?
I was just going to say they're just the slopes.
They're the slopes?
The derivative of the first graph is the slope of the first graph, and then the second derivative is just going to be the slope of the slope.
Okay, so if you didn't hear what he said the first derivative is the slope of the function graph, and the second derivative is going to be the slope of the first derivative. Dharma, what were you going to say?
I was going to say that the second graph shows like how steep the first one is sometimes.
How steep?
Yeah.
Okay.
How fast it accelerates.
How fast it accelerates? Velocity, yeah. Okay. So you're given a graph right here. So just looking at this graph, what do you know about this graph that relates to the first derivative graph? What do you remember we've learned about looking at this picture, this graph here, that we can relate to the first derivative graph? Rona? The minimum, maximum have a slope of 0. Okay, so where is your min and max located on the function graph? What? Negative 2 and 2. So what would you call this point? That's your min. Okay. And what would you call this point? And you said they had a slope of 0. So where would we put it on the first derivative graph? Where? The x-axis. And where on the x-axis would I put those 2 points? Negative 2 and 2. Okay, so what am I going to label the negative 2 as? What point? What does it represent? The min, yeah. And this one was the max. Nice. Good job, Rona. You did great. Okay, do you remember anything else about what is on this graph that we can relate to the first derivative? Zach?
If it's a max, it's going from positive to negative. And if it's a min, it's going from negative to positive.
And what do you mean by the positive, negative, negative to positive?
It's a negative slope going to a positive slope.
Negative slope going to a positive slope? Okay, so for the whole class, so what kind of slope would this be representing? Negative. And in pre-calculus, we said the graph is what? What is the graph doing right here? It's going down. What's another word for going down?
Negative. What?
Starts with a D. Decreasing. Okay. Good job, you guys. Good job. Okay, so we know that this is doing what again? Decreasing, and it has a what type of slope? Negative slope, okay. Here we know it's decreasing. And where would I draw that on the first derivative graph? Below the x-axis, connecting to what? Negative 2. No. Is it decreasing anywhere else on this graph? So, Kat? 2 to the negative infinity. So here it's decreasing. And where would I draw it over on this graph? 2 to negative infinity. Okay. Okay, so we discussed decreasing. So what else should we discuss then? Increasing. Okay, so where is it increasing at? Negative 2 to 2. Okay. And where would I draw it on the first derivative graph? Zach?
Negative 2 to 2 on positive slope.
Positive slope. Awesome. Beautiful. So those are the basics that we've learned so far. We've learned about minimum maximums. They have slope of 0, so that means they're on the x-axis. Decreasing slopes are negative slopes, so they go below the x-axis. And increasing slopes are positive slopes, so they go above the x-axis. Okay, so here are going to be the new words that we're going to be learning for the second derivative. Okay, one of them is called point of inflection. So say it back with me. Point of inflection. Okay, so the point of inflection is where the graph changes concavity. So we're going to talk about concavity. So say the word concavity.
Concavity.
Okay, and we're going to have two types. Just like increase, decrease, we're going to have concave up and concave down. So something that sometimes with the graphs it's really easy to see the concavity. Sometimes it's not. So when we're talking about concave up, you can do sort of like a hand gesture like this. Okay, it's opening up. Okay, it's opening up to the heavens. Okay, concave up. Sometimes it looks like this. Is it still opening up? Is it still opening up? Okay. Obviously, you can also have this. This is concave up. Okay, and then you have concave down. So it can like curve like this. Is that curving down? Kind of curving down, curving down. Okay, so where on the function graph do you see concave up? So where? From what intervals? So just at negative 2 you just see concave up? So negative infinity to where? To 0. Okay. Okay, so that is our concave up. Okay, so concave up on a first derivative graph is going to be what kind of slope do you think? So think about the word concave up. What kind of slope do you think up would represent? Positive slope. So where on this graph do you see a positive slope? Negative infinity to 0? Yep. So like right here. Okay, so this is going to be a positive slope, which represents concave up. Okay, so that's the positive slope of our first derivative graph. Okay, so On the second derivative graph, where do you think concave up would be located then? If concave up is the slope of the first derivative. Above the x-axis? So, Kieran, do you want to repeat what you said about slopes on a derivative graph? Where do positive slopes go?
Just said that it was the slope of the slope. If the positive slope go on the positive side of the x-axis.
And what's the positive side of the
Y-axis.
what's the positive side of, so where do we put positive slopes here?
Above the x-axis.
Yeah, so this will be still positive slope, and this will be negative slope. And Dharma, what did you say? Where am I going to draw the concave up?
On the positive side.
On the positive side. And where did it stop at? 0. Okay, so I'm going to draw to 0. And this is going to represent concave up. Okay, so we've done concave up. Now we have to do concave down. So where's concave down located on our function graph? 0 to infinity. Okay. This is concave down. And where would I sketch concave down on the first derivative? Say it loud, Zach.
0 to infinity.
Awesome. That's beautiful. Okay. So 0 to infinity. So this is then, for the first derivative, this is what type of slope on the first derivative graph? Yeah, so it's a negative slope. So it's representing concave down. Okay, so where am I going to draw it on the second derivative graph? Down from where? Where am I going to start at? From 0? Okay, we have one more word to discuss, but something I want you to notice here. What kind of function do you think this is representing? X cubed. What do you think this is representing?
X squared.
And what do you think this is representing? X, so linear. So what's happening? What happens when you take the derivative? You take off an exponent, you take off an x. Yeah, so we have x cubed, x squared. Does this represent a x squared graph? Does this represent a linear graph, single x? Nice. Okay, so the last part, it's a critical point, kind of like the mins and the maxes, is the point of inflection. So the point of inflection is one point where the concavity changes. So it changes from concave up to concave down, or concave down to concave up. Where do you see the point of inflection on the first derivative, or the function graph?
0.
It's at 0. Yeah, it's right here. And I know yellow doesn't show up very well, so I'm going to write. This is our point of inflection. Okay, so where am I going to draw my yellow star on the first derivative? Where do you think the point of inflection is going to be at? 0. Am I going to draw it here? Where am I going to draw it? At the max. Yeah. So now the point of inflection is going to either be your max or your min of your first derivative. And where am I going to draw it on the second derivative? At the 0, 0. Does this have a slope of 0 right here? Is this where slope of 0 exists? Okay, good job. Let me write those words up there real quick. So we have point of inflection. And this is our point of inflection. Okay, so another word I just want to make sure we're all sure about. In this unit, your book and some of your notes and your practice is going to refer to a word that means all the mins and maxes. Does anyone know of a word in math that means all the mins and maxes? Yes. Extremas. Yeah, it's our extremas. Good job. Well done. Yeah, so you're going to hear that word a lot. So if you hear the word extremas, that means it's talking about your mins and your maxes. point of inflection is its own separate point because it's just about the change in concavity. And there can be several points of inflections. So if you have a really curvy graph, you're going to have several points of inflections because it's going to be where the concavity changes. Okay, so I just want to get a little check-in. Can you show me with your arms, what does it look like to be concave up? Okay. Okay, what does it look like to be concave down? Okay, nice. Good job. Okay, so stay seated there. We're going to do an activity. Okay? So just stay seated. I'm going to give you the instructions, and then when I say go, then you can get up and move. Okay? So we're going to do a post-it activity. So these are the things that you will need. First of all, you need 4 members. Doesn't have to be your squad members. It can just be 4 people. Okay? Each person needs their own pencil or pen. Each person will need their own piece of paper because you're going to be turning in this piece of paper to me. When you get all that stuff, you're going to go around the room and just find like a blank wall space. So like here's a blank wall space. You could use the bulletin board as blank wall space. There's wall space behind there. There's the cupboard. There's the whiteboard. So you're just finding some wall space because you're going to stick your sticky notes on the wall. Okay, so you're going to be sticking your sticky notes on the wall. You need to send one person from your group up to me so that I can give you 4 Post-its. Okay? If you can only be in a group of 3, I will make adjustments. That's okay if you have to be in a group of 3 because I don't think we have an even 4. Does anyone have questions on the directions before people get up and move? Okay, go ahead and get in your groups. You're going to be in 3? Okay, you still are going to have 4 Post-its, and I'll give you instructions for if you're a group of 3, okay? So you still need 4 Post-its, but it's okay. Okay? Okay, how many are in your group? There's 4. Okay, 1, 2, 3, and 4. How many are in your group? 4. Okay, so you guys need to find a wall space. Wait, here you go. Here you go. How many is in your group? 4. Do you guys find a wall space? Okay, make sure you find a wall space. How many are in your group?
4.
4? Okay, so make sure you find a wall space. Okay.
Just 2. It's just me and Christian.
Okay, we might have to fill in full, so just wait a minute. There's 4. You have a wall space? Okay. Does anyone not have a group? Okay, they need 2 people, so you can join their group. Joey, do you have a group? Joey, do you have a group? Yeah. Okay, I wasn't sure. Okay, so 1, 2, 3, and 4.
Thank you.
Okay, does everyone have a pencil and a piece of paper? Okay, does everyone have wall space? Does everyone have 4 Post-its? Okay, awesome. Here's our next step. Okay, write your name on your paper because you're going to be turning it into me. Write your name on your piece of paper. Rona. Write your name on your paper. Okay, next step. So with your paper, and I will show you an example, you're going to draw an arc from one corner to the other corner. So it's going to look like this. See if that'll fit. Okay, so you're going to draw an arc with your Post-it. My group of 3, Oh, you have 4? Everyone has 4? Okay, beautiful. Okay, so then go ahead, draw an arc. Each person needs a Post-it. And draw an arc from one corner to the opposite corner. So everyone needs a Post-it and draw an arc. Okay, someone give me a thumbs up when all 4 of you in your group has done that, so I know to continue with the directions. Okay, so we just have a few more groups. Okay, so everyone should have their own Post-it. We're good? Okay, so here's the next step. Okay, our goal is we are going to connect these arcs to make a continuous graph. So one corner will connect to the other corner. Now I need you in your group to decide who's going to be person 1, person 2, and person 3, and person 4. So decide in your group who's going to be 1, 2, 3, or 4. I'm going to give you specific ways to form your Post-its. Okay, does everyone decided who's person 1, 2, 3, and 4? Can get a little thumbs up? Karen, did you guys decide who's going? Okay. Haley, did you guys decide who's first, second, third, and fourth? Okay, so each person is going to have a specific direction, so I need you listening up here. Okay, so person 1. Okay, we'll wait for Alessandra. Alessandra, go ahead and just join a group, okay? You can go ahead and join them if you'd like. Just set your bag down and go ahead and join them. And get out a piece of paper, okay? Okay, so person 1. Position your Post-it so that it is concave down and increasing. So person 1, stick it to the wall so that the arc is concave down and increasing. Stick it to the wall. You should have 4 Post-its. You only get 4. She'll still be involved in the activity. Okay, I'm waiting to see it stuck in the wall. Person 1, put the Post-it concave down and increasing. So think about what that would look like. Okay. Look at your arc. Is it increasing? Is it concave down? Okay, person 2. You're going to connect it. So you're going to connect the lines. Okay? So your arc is going to be concave down as well, but decreasing. So connect the corners so that it's a continuous line with the Post-it concave down and decreasing. Okay, so check. Is your graph connected? Is it concave down and decreasing? Okay, here's person 3. Okay, connect your Post-it to student number 2, but your Post-it needs to be concave up and decreasing. So connect it to the second Post-it so that it's concave up and decreasing. So just check, is it concave up and decreasing? And it should be connected to Post-it number 2. Hey, Kat, did you guys get yours up? I can't see yours. You're good? Okay. Here's student 4. Here's the last Post-it. You're going to connect it to number 3, but it's going to be concave up and increasing. going to come and look at your graphs real quick. Those are looking great. Oh, nice. There you go. There you go. Okay, everyone has the correct graph. Well done. Now this is where your piece of paper comes in. So you're going to need to follow the directions. Okay. Okay, so for your next step, let me fit it all on there. It's not fit. Okay, so this graph is going to represent your function graph. Okay, so this is a function graph. So you need to sketch the graph that you have made on your piece of paper. So this is graph number 1. We're going to be doing 3 graphs. So label this number 1. Also label it f of x. So that way you know it's the function graph. Label it f of x. So sketch the graph that you've created. Label it f of x. And then once you have that on your graph, and you can talk to your teammates, I want you to label any extrema. Can anyone remind me what extrema means again? Maxes and mins. Don't count the endpoints. The endpoints don't count. Okay? And any points of inflection. So on your graph, you're just going to label, kind of like how I labeled on mine, where the point of inflection is and where the mins and the maxes are. So you're just going to label where they're at on the graph. Kind of like my graph that I did up there. And when you're done, just kind of give me a thumbs up so I can just see where everyone's at so we can go to graph 2. So you're going to label the parts on the graph, just like I labeled the parts on the function graph on the wall. Okay, can I just get a little thumbs up to just see where, if we need more time, we're all good? Okay, so here comes the second one. Now this one, I'm going to give a little bit more instructions to. Okay, so I want you to sketch the graph again and label it f prime of x. Now, this is going to represent now a first derivative graph. Okay, so you're going to have to think about it differently. If it helps, it's okay to put an axis, because for the first derivative graph, the axis is kind of important. It talks about positive slopes and negative slopes. So for your first derivative graph, it's okay to put an axis. This is where you can put the axis right through the middle of your graph. So go ahead, sketch it. Label it f prime of x, because you're going to think about this now as a first derivative graph. So if this is a first derivative graph now, in your teams, you need to discuss and identify where the extrema are located on this graph now, where the inflection point's located, and which slopes represent concave up and concave down. So you're going to label those on your graph. It's okay to talk to your teammates. So it's the same graph. It's the graph we drew. Looks like this. Okay. So it looks like that. So you're thinking about this as now a first derivative graph. So you have to think about where's the maximum located now? Where's the point of inflection located now? Where is it concave up and concave down now? And when we do concave up, concave down, remember we're talking about the slopes of the graph. What slopes represent concave up and what slopes represent concave down? So go ahead and look at the directions. That will help. Good luck in your game today. I like the tie.
Thank you.
Yes. So that's your now, it's the same graph. graph, and now you're going to think about it as a first derivative graph. So you're done with this. You're done with this. So redraw the same graph, like how I have it there. And now just label the points that are bulleted. Okay, so this is a first derivative graph. Where are the mins and maxes located on a first derivative graph?
So I don't get. Do you want me to draw
No.
f of x or just
Nope,
first
this is,
derivative graph?
we're ignoring this. This is
Okay.
now, we're thinking of it as a derivative graph. If this was given to you as a derivative graph, where would you locate the mins and max?
There,
Oh, I thought we were
zero.
taking the derivative of fx, and I was very confused for a moment.
That's okay. Where is it located? Point to me. What are you talking about?
This and this.
Those are not the min. That's not where a min and max is located on the first derivative. Where's the min and max located on the first derivative? Don't look at that. Look at this. Where do we have the mins and max located on the first derivative?
On the y-axis.
On the y-axis?
Yeah. I mean x.
On the x-axis. Okay, so where on the x-axis would you have a min or a max? No, with this graph.
Oh, this is so confusing. Okay,
I
here.
know, I'm making you think
Here and
about
here.
it.
No, I know how to do it. It's like your wording makes it so much harder.
I'm sorry. So where do you think a min or a max would be located on this graph that you drew?
Here and here.
Okay, don't do endpoints. Don't do endpoints. Oops, sorry. Okay, so you guys, you have to think about it differently because if you need to, you can look here about where mins, maxes, concave up slopes, concave down slopes are located. Okay, so this graph is now representing a derivative graph, so you have to think about it differently. You have to think above the x-axis are positive slopes, below the x-axis are negative slopes. Think about the slope of concave up, concave down. Think about where a min and max might be located on this graph with the picture that you have on your paper.
These points is concave down.
No.
This was the truth of that,
And
so
then-
I'm just redoing it.
That's okay. And then where would be the slopes of concave up and concave down?
So this is going to be going from 0 or negative or positive to 0 to negative.
Yeah, so you're going to label the slopes like how I did.
So,
Yep.
yeah.
Do you guys get it? Did you label the concave down? Okay, so this says the slopes that represent concave up and concave down. So here we have a slope representing concave up. Here we have a slope representing concave down. Okay. Get it? Yes. Very nice. Excuse me, honey, I'm going to walk by you real quick.
You just gotta remember.
I know, it's different. You have to think about a first derivative graph differently.
So this is the slope graph.
Okay, so for this, you need to think about what slope represents concave up and concave down. So what kind of concavity would this represent?
That would be concave.
This is a positive slope.
Oh, yeah, concave.
Because this is a first derivative graph, so we think about it differently. Okay, let me check in over here. Let me see what you guys, can I see one? Yes, concave up. Yep, those are good. Nice. Did you guys figure it out?
Concave up, concave down, concave
Mhm.
down, concave up.
And where's your, okay, so can you erase your min and max? Because so
I thought we used the same graph for like everything.
we are, though we're going to use the same graph for a second derivative, but it's,
Oh.
okay, nice.
And it's concave up again. Is it concave up in these two portions?
Are
Is
those
positive?
positive slopes for that graph? Yes.
Okay.
And where's concave down?
This middle portion.
Yes.
Okay.
Well done. And where do you think your point of inflection is going to be now that you've done that?
Wait.
So this is a first derivative graph, so look at where we put our point of inflection. So where do you think the point of inflection will go?
Is it
Look, is it?
here?
Mhm. Yep.
Is that where the concave up and concave down?
Oh, right.
Good
Wait,
job.
would there be one here too?
Yeah.
Okay.
Because do you have a change in concavity?
Yeah.
And then where would a min or a max be located?
At the X.
Yes. There you go. Good job, you guys. Good job. Okay. It looks like everyone has the graph, so let's just clarify real quick and make sure we're okay with this. So looking at this graph, okay, where did you say a min or a max was located at on this graph? Zeros on the what? On the x-axis, so like right here. And I know some of you continued your graph here, so that would be fine. Okay, so there's your min or your max. Do you think this is a min or a max? Which one do you think this is? And why is it a max? Positive to negative. Okay. So where did you say your point of inflections were located? The max and the min of this graph. Okay. And where's the graph showing concave up? On a first derivative graph, where do we see concave up? Slope of derivative is positive. And if the slope of derivative is negative, concave down. Okay. So we're going to have the same graph. So you're going to draw the same graph, just like this, but we're going to have it be a second derivative graph. So we're going to think about it in terms of a second derivative graph. Okay? So you got to think about what is represented on a second derivative graph. So it's the same graph, but now we're calling it a second derivative graph. So second derivative graphs are about concavity and points of inflection. If you need to, you can refer to my poster that we have over there for the second derivative. So this is what you're going to identify and label. Okay, so you're going to identify the point of inflection, or point of inflections if there's more than one. And you're going to identify what part of the graph is representing concave up and concave down. So again, you can refer to this picture here to help you identify on your graph. You're just identifying the point of inflection and concave up and concave down. If that was the picture that was presented to you, where would you have concave up and concave down?
Yes.
So what are you thinking, Jen?
Because we don't really mark the min or the max on the.
Mm-mm.
So is it just all of this? Because here, like, the slope is positive, but.
So positive slope. So above the x-axis is representing all the positive slope, which is concave up.
Okay, so all of it's.
Yeah.
Sure.
Where's your third? Okay,
This
so
is my third.
okay, so we're not doing min and max because it doesn't show min and max. We're just doing point of inflection and what part of the graph represents concave up and concave down. So what part do you think is representing the concave up part of the main function? Just that, or can you like? Yeah, the whole thing. Yeah, good job. What did you guys decide? Ooh, nice. Yes. Ooh, that's good. Oh, nice. Yes. Yes. Rona, did we get it?
This is the point. This is concave up. This is
Okay.
concave.
I need you to still label this for me because it's going to be turned into me. Okay, that is really good. Okay, it made you think a little bit because you had the same looking graph, but it represented different things depending on if it was a function graph, a first derivative graph, or a second derivative graph. So now I'm going to have you go back to your seats, okay, or just pick a desk. Just go ahead and sit in a desk, okay? So just go ahead and sit in a desk somewhere. Doesn't have to be your desk, just in a desk. You can sit anywhere, Kat. You can just sit at a desk. Okay, so I just want to check in because I noticed that everyone had similar answers, but I just want to be sure. If this was your second derivative graph, where did you say the point of inflection would be located? Okay, what? At the zeros on the x-axis. So if this was continuing this way, we'd have it here, here, and here. Okay? Where did you label concave up? What represented concave up? If this is a second derivative graph. What's that?
What?
You're not sure? What did you put on your paper?
From the point of inflection to the other end.
To here to here? So, can someone phrase? Yeah, you guys are correct. So, we would say that concave up is where? Yes. It's above the x-axis. Awesome. So, where are we going to have concave down? Below the x-axis. So, this whole thing is representing concave down. And when we say that, we're saying that this is the second derivative of some function, okay? So this is the second derivative of some function if we were to integrate it all the way back. So we're saying that main function that we don't know what it is concave up from here to here, and that it's concave down from here to here, the main function, okay? So that's what you're doing, is you're identifying the parts for the main function. So this is going to be an individual activity now, and then you'll be turning in your paper, okay? Okay. So I will zoom in on this a little bit. I just want to make sure the whole... Yeah, I know the whole directions aren't staying up there. We'll autofocus that. Okay, I'll fix the clarity of that. So you're going to write your own definition of these 7 words that we are talking about. Okay? It's your own definition or understanding. You can also sketch a picture to demonstrate your understanding, if that helps you. So on your own, these are the 7 words. We have maximum, min, increasing, decreasing, point of inflection, concave up, concave down. You're going to write your own understanding of what those words mean. And if you need to, you can sketch a picture to represent your understanding. I'm going to adjust this a little bit so it's a little clearer. And you can write on the front or the back, but for each word, you're writing your own definition or understanding. If you want to do a picture, you can do that. You can do it, Rona. You can do it. Yes, this is your practice for today. You don't have homework tonight. This is your practice for today. I know. Oh, yeah. Yes, so Rona, yes, this is being turned in. Do you want to maybe talk about it in terms of function, first derivative or second derivative maybe, too? So you guys, when you're talking about your understanding, it's okay to also kind of talk about what it means in terms of a function, but what else does it mean in terms of like a first or second derivative? Okay, so be a little bit detailed. So I know you're probably writing this in terms of the main function, but kind of address what does it mean with the first and second derivative. Guys have plenty of time. We still have 9 minutes left of the period. Doing great. Can you label what those are for me? When you're done, you can hold up your paper and I'll come around and collect it. Awesome. Okay, so now that you're had time to think about it, would anyone be willing to share what their ideas of a max or a min? Anyone willing to share? Someone be brave. Yes, Jan.
When the slope shifts from going from a positive slope to a negative slope.
So that would be is that a max or a min?
A max.
A max, so she said it's when the slope shifts from a positive slope to a negative slope. So what can we assume for a min? Negative to positive. Okay, getting ready to put that away. Okay. What about point of inflection then? Because the point of inflection is a special point too. So how would we identify that? Yes.
A point in which the concavity is changing.
A point in which the concavity is changing. Would you agree with that? Awesome. Okay, so our new words were concave up and concave down. So would anyone like to describe the concavity? What does that mean? Like concave up or concave down? Logan?
It's the area trapped between the arms of a graph. So if it's like a quadratic, it would be the area between the negative and positive sides, or on the things up on the graph.
So you're talking about the main function with the arms of the graph.
So it's the area, if it's below the graph, it's concave down. If that area is above the graph, then it's concave up.
Is that with the function or with a different graph?
It's with the function. With the derivative graph, it's where the slope of the derivative is positive if it's concave up. When it's concave down, the slope of the derivative is negative. And on the second derivative, if it's above the x-axis, then it's concave up. If it's below, then it's concave down.
Nicely done, guys. Well done. Okay, so you guys did an excellent job today. I'm super proud of you. Tomorrow we will have notes starting Unit G. So this was our introduction, just so you guys have kind of a preview of what we're going to be working with for this unit. Bless you.
Thank you.
Okay, so you can go ahead and gather your stuff. You have about 2 minutes left, and you have no homework tonight.